Okay, this next one is gonna be it's gonna be single replacement again, but this one's be metal and an acid. Okay. All right, so we're gonna take 1 gram of solid magnesium, and we're gonna put in 500 mils of 3 molar hydrochloric acid. And what we want to do is find out how many liters of hydrogen gas are formed. Okay, pressure is 1 atmosphere, temperature is 25 degrees C. Why do we need to know that? Because we're going to be using the ideal gas. All right, so get the balance equation and then set up the recipe table. All right, and then what we're going to do is figure out moles, then figure out recipes, and then limiting reactant. So we have solid magnesium, so we're going to be using molar mass. So we divide by its molar mass and we get 1 divided by 24.3, and that's how many moles of magnesium we have. Okay, figure out the moles of hydrochloric acid, change the molarity to moles per liter. Okay, and then multiply. And also you want to change 500 mils to liters. That's going to be 0.5. And so it's going to be volume times molarity equals 1.5 moles. Okay, the next thing is to figure out how many recipes. And then, so find the number of recipes and then find out which one is the limiting reactant. So divide the amount of moles by the recipes. Okay, and you get 0.041 for magnesium and it's 0.75 times with hydrochloric acid. So it's obvious that magnesium is going to run out before you run out of the hydrochloric acid. Okay, so this is how many times the reaction will take place with these quantities. Okay, next thing to do is figure out how many moles each one is formed, and then from there you're going to figure out how many moles of oxygen, how many liters of hydrogen you're going to produce. Okay, so recipes times moles per recipes tells you how many moles you get. This is the one we're interested in, so we're going to make 0.082 moles of hydrogen, H2. Okay, and now what we do is find out how many liters that is. It's a gas, so we're going to use the ideal gas law. Okay, so we just plug everything in. So the ideal gas law, solve for V, nRT over P. So we have, here's N. Now, these two numbers look alike. That's just a coincidence, okay? So this is the number of moles. This is N. This is R. This one we had to figure out. This is the temperature divided by the pressure, 1 atmosphere. Okay, remember you had to change temperature to Kelvin. Okay, and then when you do that, you end up with 2 liters of hydrogen gas. Okay, right, so there you go. So again, this is going to be a single replacement metal plus an acid.